In this video, we shall learn how to write decimal representation of m by n for all mn in a very simple way. Mn, natural number. We shall first compute 1 by n, then from its decimal representation we shall write decimal representation of m by n for all mn. So suppose we wish to find decimal representation of 1 by 7. So once I find decimal representation of 1 by 7, from that decimal representation I will compute 2 by 7, 3 by 7, 4 by 7, 5 by 7, 6 by 7, and any number divided by 7 can be find out from the decimal representation of just 1 by 7. So in order to find decimal representation of 1 by 7, what we need to do? So first write remainder, and below remainder write quotient, and above remainder write one digit 10. This I will call a multiplier. So in remainder line write 1, in quotient line write 0 point. Now the method is first multiply 1 with 10 in mind and divide that number by 7. So after dividing, write quotient here and remainder here. So 10 when divided by 7 we get 7 ones are 7, the remainder will be 3. Now multiply 3 by 10, 30, and divide by 7. 7 fours are 28, remainder will be 2. Now multiply 2 with 10, we get 20. 7 twos are 14, remainder will be 6. So multiply 6 by 10, 60. 7 eights are 56, and remainder will be 4. Now multiply 4 with 10, 40. 7 fives are 35, remainder will be 5. Now multiply 5 by 10, 50. 7 sevens are 49, remainder will be 1. Now stop this process because 1 has already occurred. So when is digit in the remainder line repeats, stop the process there. So the decimal representation of 1 by 7 is now this line, 0.142857, and now repeat this 14287 dot. So this is non-terminating reoccurring decimal representation of 1 by 7. So once we have representation of 1 by 7, from this representation I can compute 2 by 7, 3 by 7, 4 by 7, and any number by 7 can be computed just from this line. So see, for example, I want to say 4 by 7. So what is 4 by 7? One way is multiply this thing by 4, but that is very hard. How this infinite representation can be multiplied by 4? So I am not going to multiply this thing by 4. So magic is here. So in remainder line, see where the 4 is written. So 4 is here. So start from a number which is just below 4 and start writing from this. So this is 0.57. No, 57. Repeat this thing. 14287 142 dot. So this is 4 by 7. Suppose you want to write 6 by 7. So what is 6 by 7? 6 by 7 is, say, where the 6 is written in remainder line. Number 8 is just below 6. So start writing from 8. So this is 0.857, then 142, 142, 857, 857, dot dot dot. Suppose you want to write 37 by 7. 37 by 7. Now 37 by 7 can be written as 7 5s are 35 plus 2 by 7. So 7 5s are 35 plus 2, 37 by 7. So this number can be written as this. So this thing is equal to 5 plus decimal representation of 2 by 7. So where 2 is written, start from a number below that 2. So this is 0.2857, then repeat 142, 142, 857, so on. So decimal representation of 37 by 7 is 5 plus 2 by 7, and 2 by 7 we know how to write. 2 by 7, start a number just below the 2 and write 0.2857, 2857, then 1428, 1428, so on, and add 5 there. So I get decimal representation of this. So it means any number divided by 7 can be represented in decimal just from the decimal representation of 1 by 7. So let's do one more example to make this point clear. Now suppose we wish to write decimal representation of 1 by 13. So again write one line for remainder, one line for quotient, and one is multiplier, that is fixed number, that is 10. So in remainder line write 1, in quotient line write 0 point. Now multiply 1 by 10 and divide by 13. So 13 zeros are 0, the remainder will be 10. So write here 10. Now multiply 10 by this 10, so we get 100. So 13 sevens are 91. 100 minus 91, 9. So 9 tens are 90. So 13 6 are 78, and 90 minus 78 is 12. Now multiply 12 by 10, 120. 13 nines are 117. So 120 minus 117 is 3. So 3 into 10, 30. 13 twos are 26. 30 minus 26 is 4. Multiply 4 by 10, 40. 13 threes are 39, and 40 minus 39, remainder is 1. Now 1 has reoccurred, so stop here. So now the answer is 1 by 13 is equal to 0.076923, and then repeat this thing from this 0.076923, so on. So this is non-terminating reoccurring decimal representation. So from this decimal representation we can find 2 by 13, 3 by 13, 4 by 13, 5 by 13, and any m by 13 can be obtained from this expression. So let's see. Suppose I want to write 9 by 13. So 9 by 13 is, see, a number which is just below the 9 in the quotient line. Start from that number. So this is 0.6923, then 076 dot. So 9 by 13. Now suppose you want to write 2 by 13. Now in order to find decimal representation of 2 by 13, and 2 is not appearing in the remainder line, so I erase all this and start finding decimal representation from beginning of 2 by 13 instead of 1 by 13 by using this method. So 2 by 13. So in one line write remainder, another line quotient, and one is the multiplier. So in remainder line I write 1, in quotient line write point, 0 point, and instead of starting from 1, start here from 2. Now multiply 2 by 10 in mind, we get 20, and divide by 13. So 13 ones are 13, remainder will be 7. So multiply 7 by 10, we get 70, divide by 13. 13 5s are 65, remainder will be 5. 5 multiplied by 10, 50. 13 3s are 39, and remainder will be 11. 11 10s are 110. 13 8s are 104. We get remainder is 6. 6 10s are 60, and 13 4s are 52. Remainder is 8. 8 10s are 80, and 13 6 are 78, and we get 2. So 2 is already here, so we don't need to write 2 again. So my answer is 2 by 13 is this thing, 0.1538461533846. Now from these remainders I can write 7 by 13, 5 by 13, 11 by 13, 6 by 13, 8 by 13. And from the previous calculation of 1 by 13, the remaining quotients could have been computed. The remaining ones were 1 by 13, 3 by 13, 4 by 13, 7 by 9 by 13, 10 by 13, 12 by 13. So these 6 can be obtained from the decimal representation of 1 by 13, and these 6 can be obtained from the decimal representation of 2 by 13. So you can try writing these decimal representations. Most of the cases, if you write a decimal representation of 1 by n, you will be able to obtain decimal representation of m by n. And wherever you can't obtain decimal representation of m by n, just try 2 by n or 3 by n. These will work to get the decimal representation of all m by n. So thank you very much.